This is basic VHF and UHF fundamentals. Let's talk briefly about radio spectrum. The radio spectrum actually starts out about 3 kHz. The area between 3 kHz and 30 kHz is called VLF, or very low frequency. This area is primarily used for submarine traffic. Low frequency, or LF, is from 30 kHz to 300 kHz. LF is used from everything from navigation to time reports. MF, or medium frequency, is from 300 kHz to 3 MHz. The most recognized use for this band is the AM broadcast band. Then we have HF, or high frequency. This band goes from 3 MHz to 30 MHz, commonly referred to as the shortwave band. Next is VHF, or very high frequency. This goes from 30 MHz to 300 MHz. This is where you'll find FM broadcast stations, as well as some TV stations. Then on to UHF, ultra high frequency. This goes from 300 MHz to 3 GHz. You'll find most television stations in this area, as well as cell phone coverage and Wi-Fi. Then we have SHF, or super high frequency, which goes from 3 GHz to 30 GHz. This is where you'll find most of the satellite stuff. If you have satellite TV reception, this is the area it's in. Then there's EHF, extremely high frequency. This goes from 30 GHz to 300 GHz. Typically what you find in this spectrum is a lot of scientific research, as well as some data transfer in the lower part of the spectrum. We're going to be discussing VHF and UHF fundamentals. So what's so special about VHF and UHF? It uses line of sight propagation. Line of sight is the direct propagation of radio waves between antennas that are visible to each other. This is probably the most common of radio propagation modes at VHF and higher frequencies. The maximum distance of line of sight transmissions with two people standing on the surface of the Earth is roughly 25 miles. This is due to the curvature of the Earth, often referred to as the radio horizon. It is slightly further than actual sight, since radio waves do bend. However, the higher the frequency, the less they bend. You can extend the range of your communications on VHF and higher frequencies by increasing the antenna height. 10 feet of antenna height is like doubling your power output. This is why a repeater on a high point is so effective in extending range on VHF and higher frequencies. Another thing to do is pay attention to your antenna and feed line losses. Losses are much higher at higher frequencies for the same given length of antenna feed line. Because VHF and UHF radio signals can travel through many non-metallic objects, radio can be picked up through walls or buildings. UHF is better for this due to the shorter wavelength. This is still line-of-sight propagation. Best example of this is a television transmitter. However, ground plane effect is an important factor in line-of-sight propagation, and sometimes moving just a few feet can make a major difference in reception because of what's called multipath. Radio waves can be diffracted around sharp objects, such as buildings or other solid objects. Mobile communications can be alternatively good and bad, causing a fluttering known as picket fencing, kind of like seeing light through a picket fence. So what's all this stuff mean? Let's give you an example. WAPL FM and WGBA channel 26 both have towers within a few thousand feet of each other. As you can see, WAPL FM running 100,000 watts has a coverage area from Sturgeon Bay all the way to Fond du Lac, whereas WGBA channel 26 running a megawatt of television signal has almost the exact same coverage area. So what does FM and TV broadcasts have to do with ham radio on VHF and UHF? A lot. Think of your TV signal. If you receive over-the-air television, it's very similar to Simplex. The TV tower transmits it, and you receive it one direction. With 2 meters and 440, we can do Simplex operation as well, transmitting from one radio to the other on the same frequency. That's referred to as Simplex. So we're driving down the road, and we want to talk to our buddy, and he's not very far away. We don't need the repeater. We can use Simplex. In this case, 146.52. And Simplex, we're usually good for about 10 miles or so. So let's talk about duplex operation. Basically, the way duplex operation works is we transmit on one frequency and receive on another. The frequency we transmit on is the receive frequency for the repeater. Here's a basic repeater block diagram. It picks up the frequency that we're transmitting on, receives it, it comes through the duplexer, then it comes into the receiver. That receive audio goes to the controller, which turns on the transmitter and transmits the RF out through the duplexer. An example here would be on 2 meters. We transmit on 146.16 to the repeater. The repeater receives that signal and retransmits at a 146.76. So now once again, we're traveling down the road, talking to our buddy, but we're many miles apart. So we transmit on 146.16. That signal goes up to the repeater and is retransmitted at 146.76, where our buddy's listening for us. Then when we're done talking, the transceiver in our vehicle switches and goes from transmitting at 146.16 to receiving at 146.76. So our buddy can talk to us, and when he transmits, he'll transmit transmit on 146.16 and we'll be listening at 146.76. So here's a coverage map of one of our local repeaters. As you can see from the map, as long as you're in the blue circle, you can hear the repeater. So for example, a gentleman on his way up to Green Bay can talk to a person in Fond du Lac without a problem due to the height of the repeater, which allows for more line of sight transmission. So now let's say that one of the guys found himself a heck of a fishing hole in Wapaka, but he still wants to talk to his buddy in Sheboygan. How are you going to do that? That's where we mix Simplex and Duplex together, commonly referred to as Crossband Repeat. It allows you to turn your vehicle or base radio into a repeater of sorts. It allows our friend to take a small handheld radio and transmit that signal to his vehicle, which in turn retransmits on the main repeater input frequency. Then when it comes to receive, it receives the main repeater and retransmits the signal back to the handheld radio. This is simple crossband repeat. So that's the fundamentals of VHF and UHF line of sight transmissions. I hope this video has been helpful, and 7 threes from N9 LVS.